Lesson 54 is polar coordinates and similar triangles. We're actually going to hop to that second topic first, the similar triangles topic, and get that out of the way. We've done a lot with similar triangles over the last few years, so this is a little twist on that in your book. They're not going to tell you they're similar triangles, but you know that they are. You guys are so smart. Plus, you know that if you have one set of angles marked congruent, you know that this pair of angles is also congruent because vertical angles are always congruent. And you know that if two angles are congruent, then what? Then the third angle pair is congruent as well. So we know that that last pair there, the bottom left, bottom right, those are congruent. When we have three congruent angles, we have a similarity. So let's read the text. It says, use A, B, C, and D to write a proportion. So here's the deal on these. No numbers. You're not really solving for anything. This is more just an abstract problem. Use those letters to write a proportion. Well, great. You know how to do that. Okay, because the corresponding sides, ratios of corresponding sides are proportional. So if I start with A corresponds to what in the right triangle? A is opposite the triple marked angle, so that goes with, it corresponds with B. So I say A is to B as C is to D, right? Because C is opposite the single tick mark, and so is D. So A is to B as C is to D. So we wrote our proportion from our similar triangles. What's next? It says then solve for D in terms of A, B, and C. It just means take this equation and rewrite it so that it says D equals stuff, okay? And so we know how to do that. If we have a proportion, we can cross multiply. So cross multiply A times D equals B times C. And then to isolate D, we simply divide both sides by A. Therefore, D equals BC over A. And that one is done. The one that they have in your book for the lesson that goes, for the set that goes with this lesson. And Rowan, did you have a question? Oh, you could, but then you would have 1 over D equals, right? You would have the reciprocal. Yeah. So oftentimes, yeah, and you know what? The other thing we've talked about, I just noticed this. Remember, we've talked about, like with our trig stuff, if the variable we're solving for is in the denominator, if we have a proportion, we're allowed to swap along the diagonal, right? So you could approach it like that. So you could do D, B stays the same. So you're just swapping A and D along the diagonal. Let's see what happens with this. And then if you want to isolate D, then you can multiply both sides by B, right? And they cancel, and you have D equals CB over A, which is the same thing here. Let me show you what it's going to look like in your book. Yeah, this is what they're going to look like. They're going to stick that set of similar triangles inside of a circle. So just don't be thrown off by that. It's the same type of problem where they're going to ask you to use the 4 variables to write a proportion and then solve for one of the letters in terms of the others. When it says in terms of S, T, and B, it just means, R is going to be on one side of the equation, and then all the others are going to be on the other side. And that's all that means. Well, let's go back to the beginning of our lesson. And I want you to take really good notes today. Polar coordinates. This is more fun with trigonometry. Polar coordinates, what is a polar coordinate? Well, this right here is a polar coordinate, where it says 4 at 57 degrees. And what exactly does that mean? Well, polar coordinates are just another way to name a point. Another way to name a point. What do I mean by that? Well, let's get a grid here. And you don't have to write this down, but if I tell you to go name the point 4, 3, you would say, well, that's an XY coordinate, right? So we would go on the x-axis over 4, and on the y-axis, we would go up 3, and we would find that point. To this point, this is the only method that you've used to find points on a grid. There's another way to find points on a grid, and that's by using kind of a circle. So when you hear polar, do you think of something like the North Pole, the South Pole? I don't know, maybe polar bears, but they live at the pole, right? So what we want to think of is a circle and the center. So if if you're in outer space and you are looking down on the Earth, if you're up above the Earth to the north, you look down and you see the North Pole. So this is similar to the origin of our XY coordinate grid. So I could give you an angle. When we think of circles, we think of angles. So we always start here at due east. And we always count counterclockwise in math. So we go around. I could tell you to go find this point by traveling 57 degrees. That would be my angle. And then what does this 4 mean? The 4 would mean this would be the length, okay, from the origin. So I could say, if it's a circle, go 57 degrees, find that, and then from the origin, go out 4 units. Boom. Something like that. That's a way to find a point. That's exactly what we're going to do here. We're going to find this point in polar. So this is called polar coordinates, where we have a length and an angle. This is also called a magnitude. So when you're doing science, when you're doing physics, that's called a magnitude. And so let's do that. Let's find on our grid, I'm going to get rid of this. Let's find this polar point. When we understand that we're traveling, but put this in your notes too. We always start in mathematics at 0 degrees as the positive x-axis. Okay, and then we're going to go counterclockwise always. And so if we're in quadrant 1, that's all the angles between 0 and 90 degrees. Okay, this quadrant 2 here is all the angles that are between 90 and add another 90, gets us at 180. Okay, and then down here in quadrant 3, these are all the angles that are between, let's see, we have to add another 90. So that gives us 270 degrees. And then finally, quadrant 4 are all of the angles that are between 270, and we complete the circle. So starting at 0, we end at the same place, but we've gone 360 degrees. So you can kind of see that circle there, right? So let's find 57 degrees. Let's find this point. So if I go 57 degrees, I mean, that's close to 60, which is close to 2/3 of the way into quadrant 1. Okay, so I'll call that 57 degrees. And then my length is 4. My length from what? From the origin. So I'm going to just make a line. And I don't have any markings on this, so I'm just going to just do it random out there, put a point there, and just call that 4, okay? Why? Because I said it's 4. And that's how I would get to that point. Similar to just saying, hey, go find the point 4, 3. Okay, write 4 up 3. Just another way. So now that we found the point, what does this ask us to do? Change the polar point to rectangular coordinates. Rectangular coordinates similar to this, but a little bit different. Right? Similar but different. What we're going to do is that's what we're going to learn today. How do I tell you to get to this point now basically using X's and Y's? I would say I'm going to go right in the X direction a certain length, and then I'm going to go up. Right? Making a right triangle. I'm going to go up, and we're on this grid, so basically we recognize this as Y, right? So over X units and then up Y units. Okay, so similar to this notation, only I don't want to spoil it. It's just going to look a little different. We're going to write it without parentheses and without a comma. Rectangular coordinates. So just so there's no confusion, when I write with parentheses and a comma like this one, this is called Cartesian coordinates. That's this. So we're going to do something similar, but it's called rectangular coordinates. But before we do that, we have to go find the length of X and Y. And we can do that, right? Because we have a right triangle, we have an angle and a side. And we know that if we have one angle and one side in a right triangle, we can use trig. We can use SOHCAHTOA, sine, cosine, and tangent to find missing pieces. So that's where we're going to begin. We're going to begin by finding X. So this is just trig, basic trig, you guys. You have 57-degree angle. Side X with respect to that angle is the adjacent side. 4 is the hypotenuse. That indicates cosine. So we'll set this up by saying the cosine of my angle, 57 degrees, is, so the cosine of an angle is a ratio. It's the ratio of adjacent side X over hypotenuse 4. And then to get X by itself, we multiply both sides by 4. And we put this in our calculator and we get 2.179. We're going to still be rounding to 3 decimal places. So put that on hold, right? What you just found is the length of this side of this right triangle. Now let's do the same thing to find Y. Well, y, with respect to my angle, is the opposite side. So I know the opposite side and the hypotenuse, which tells me I'm going to use the sine ratio. So I know the sine ratio, the sine of 57 degrees, is the opposite y over the hypotenuse. For continue to isolate y by multiplying 4 to each side. And we'll use our calculator, and we get 3.355. Okay, so understand what we basically have done is just find the lengths of sides x and y of our right triangle. Now, what about this rectangular coordinates? What does that mean? Rectangular coordinates okay, we're going to drop the parentheses and the comma. And we're going to write this like we're giving somebody directions how to get someplace. We're going to say like go right and then go left, or go right and then go up. Okay, so we're going to go right, left, up, down. So we're telling somebody how to get there. We're going to say, so it's always from the origin. From the origin, we're going to go right, and then we're going to go up. How far right are we going to go? That's x. We just found that, right? So we're going to say 2.179. And when you're saying something on the horizontal axis, it's either going to be right or left. So we're going right. Your book is going to use an R for right. Okay. And then we're right here on the corner, right by the 90-degree angle. Now what do? We go up. Remember, we want to get to this point right here. So we go right and then we go up. How far do we go up? We go up 3.355. So up is plus. If it was down, it would be negative. And then you're going to say the length of what you just found for y. Okay. And whenever you were doing up or down, your book is going to call that u. So right, R, and U for up. Don't get too attached to that because we're going to change the R and the U. This is what your book does, but we're going to change this. This is why I want you to take some good notes. This is what your book says. It uses R and U for the X and the Y direction. And it'll be positive and negative depending on, so negative R would be like the opposite of R, that would mean left. Okay, that means you go left. Negative U would be like opposite of up, which is down. Okay, so it's just, horizontal distance left or right, vertical distance up or down. So that's what our book does. Now, we're going to change R and U to what's called I hat and J hat. And all of the other math books, and when you do physics especially, you're going to be doing all this stuff in physics. We use I hat and J hat to denote. I hat is the X direction. So let's just substitute just what we wrote in the blue box, 2.179, and we'll put I hat, okay, and then just drop down Y value, 3.355. J hat, okay. This is how our answer should look. This is rectangular coordinates. It, in essence, tells us how to get to this, and go up to the grid again, to this spot directionally. Okay, we found the length of X. We said, hey, go a little more than 2 to the right, or I hat, and then go up a little more than 3, and you get there. So it's a lot to take in, but we'll get used to it. We'll do 2 more examples, okay? So write this. So in your book, whenever you see R's, they're I hat. Whenever you see U's, they're J hat. They go in sequential order. Okay. So X and Y in the book are R and U, but for us, they're I hat and J hat. Okay, so with that, let's just do a couple more, and we'll get the gist of it. First one, change 7 at 230 degrees to rectangular coordinates. So remember, this is called polar. Polar coordinates, it gives you a length or magnitude and an angle. Our first step is going to be to plot that point. So you need to go find the point. Recalling that we start at 0 on the positive x-axis. So let's go find 230 degrees. Ready? So we have to go, let's see, 90. Keep going. Another 90. That's 180 degrees. Keep going. Well, maybe not so much. If we add another 90 degrees, we're at 270. So we know we're in quadrant 3, yes? How far into quadrant 3 do we have to go to get to 230? Let's see, 180. We would need to go 50 degrees more, right? Okay, so that's 230 degrees. Now, what's our length? Our magnitude is 7. So from where? From the origin. Put a dot at the origin, and you're in quadrant 3. This is 50 degrees. Okay, and then just draw a random line out and label it 7. This is the point that we're going to describe at the end of the 7. Next thing, you're going to construct a right triangle to the x-axis. Always to the x-axis. And you're going to label your sides that you're going to find. Okay, we have to go find x and y. We're going to tell somebody how to get to this point. Basically, we're going to say from the origin, we're going to go left, which is negative, right? And then we're going to go down, which is also negative. But we got to find the length of those pieces. So to find x, we're using this 50-degree angle because you got to use that. By the way, you're never going to use this one, okay? Never using the calculations. Okay, it always has to be an acute angle inside your right triangle, right? Because we're doing right triangle trig. Right triangles always have acute angles. So to find x, we know x is the adjacent side. Hypotenuse, by the way, your length, 7, that's always going to be the hypotenuse of your right triangle. Right, SOHCAHTOA if you need it. To find x, we have the adjacent side and the hypotenuse. So that's going to indicate the cosine. The cosine of 50 degrees is adjacent x over hypotenuse 7. Let's set up y real quick. To find y is the opposite side of the 50-degree angle. So that indicates the sine. So we say the sine of 50 degrees is the ratio opposite over hypotenuse, y over 7. Okay, now we can solve. Okay, by multiplying 7 to each side. We do the same thing for y. And we put 7 cosine 50 in the calculator. We put 7 sine of 50 in the calculator. And we get our values. So x is 4. Yep. I will go over that in just a sec. So let's just isolate these, and let's get y is going to be 5.362. Okay, yeah, this is an important question because this is super important that you can find this 50 degrees. So my original polar notation is 7 at 230 degrees. So I start at 0 and I go find where is 230 degrees. And it's right here. It's in quadrant 3. So at the horizontal, that's 180 degrees. I have to go 50 degrees plus, right? 180 plus 50 to give me 230. Does that make sense? So you just have to you're going to do some math with the 180 here, okay, with the closest horizontal. You're like, okay, I know I'm at least 180. How many more degrees do I need to get to 230? And that's how I find 50 degrees. Great, so what we have is the length of each of these sides. And so we're ready to put it in rectangular coordinates. So remember, rectangular coordinates is always going to be, okay, the length of side x, and then we'll do I hat, and then the length of side y with the j hat. Now we put in the positives and negatives. Remember, you're telling somebody how to get there. So from the origin, we're going to go left. So we're going to go minus 4.500 I hat. All right, here we are right at the 90-degree angle. Now we go down. So down in terms of y is negative. So we say negative. Then we say go down this length, right? We go down a little over 5.362. And we call that j hat. Okay, instead of r's and u's, we're using I hat and j hat. And the reason you're going to use I hat and j hat is to prepare you for your higher math and for physics, okay, in which they use I hat and j hat. One more. You guys liking this? It's pretty cool, huh? Hopefully you're taking some good notes. This is the last one. Okay, our polar coordinates are 28 at 310 degrees. We're going to change that to rectangular coordinates. The first thing you do is you go find that on the grid. We start at 0 degrees. Okay, and we go around. So let's find 310. Okay, so we go 90. We have to keep going, right? 180. Another 90 is at 270 degrees. We keep going. Yep, so we know we're in quadrant 4 here. How far? How far? It's somewhere in here. Did someone raise their hand? 30? Well, let's see. If we go all the I think it's more than that. So if we go all the way around, it's say again. So it's 310. If we go all the way, so it's not 40. It's actually another 50. Okay, because if we go all the way to 360, that would be too far. So we have to back up, and this has to be 50. Does that make sense? If this is 310, 310 plus another 50 would give me 360. Are you guys with me? Okay, so it's super important to find that acute angle. Okay, so just have these 90, 180, 270, and 360 at the grid, at the axis marks. So my acute angle similarly is another 50. And then we're going to construct a right triangle to where? To the x-axis. And Dylan, I see your hands raised. Okay, so this is important. That would be this one. But if I use that one, I would be making my right angle to this. And it could be done, but I'm just going to tell you guys, you always want to, in math, you always want to make your right triangles when you're doing this to the x-axis. Okay, so make your right triangle with the x-axis. Okay, just so we're all consistent, and that's the way we'll do it in physics too. Okay, so yes, this is 40 degrees, but we're not going to use that. But yes, point well taken. Theoretically, you could do something there, but for consistency's sake, right triangle always with the x-axis. All right, let's go get our sides. So for x, oh, and we also need to label our magnitude. What was our magnitude again? 28. Okay, so with respect to the 50-degree angle here, we've got the adjacent side and the hypotenuse. Please notice that isn't the x always going to be adjacent? Your angle is always going to be coming off the origin here. And so x is always going to be adjacent to it. Therefore, we're always going to use the cosine whenever we're finding x. So the cosine of 50 degrees is x over 28. Okay, there's SOHCAHTOA. And notice that when we find y, notice that y, isn't it always going to be the opposite side with respect to your reference angle here, the 50-degree angle? It is. So x is always going to be the adjacent. Y is always going to be the opposite. So when we're doing y, we're always going to use the sine ratio. So the sine of 50 degrees is y over 28. So we should start to see some patterns already. All right, so for each, let's solve for x by multiplying both sides by 28. Let's go ahead and do the same thing for y. Multiply both sides by 28. Okay, and this is what you're putting in your calculator. That's what you're putting in your calculator for x and y. And let me get those for you. I've got those ahead of time. X is 17.998. Y is 21.449. Okay, before we just hop to our rectangular coordinates, you need to remember that what you just found, folks, with the x and y, you basically found the absolute value of those sides. Okay, when you're finding side lengths of triangles, there's no positive or negative, is there? You just found the lengths. Now, to tell somebody how to get to my point here, I need to give them directions. So that's where we have to put in positive or negative. So starting at the origin, I'm going to tell somebody how to get my point. So x first, I'm going right. Right is positive. So I say go 17.998, positive. That means go to the right. Instead of saying x or r, I put I hat. So now I'm here at the right angle. Now how do I get there? I go down. Okay, I know the length of that side is 21 point something, but I have to tell that person who wants to get there, okay, to go down. Down on the grid is negative, so I say minus, and then whatever y is, 21.449, what? J hat. Remember, x is I hat, y is j hat. They go in alphabetical order, right? X is followed by Y, just like I is followed by J in the alphabet. Okay, what's your book going to have? Your book's going to have, if they did this problem, the book's going to have an R there and a U here. So you need to know how to interpret that when you check the back of the book. Okay, back of the book's going to be a little different because they round to 2 decimals, we round to 3. But they should be very close. Okay, yay, you guys made it. We learned so much today about polar coordinates to rectangular coordinates. All right, so we are done. Lesson 55 is going to be a video, and I'll put that up here shortly. And I guess I'll see you next time. I won't see you till Friday at 8, but do let me know if you have questions on your on those practice problems. Okay. Oh no, I'm sorry you got kicked off. Have you been off this whole time? No, I did record this, so once I get the video finalized, I can put that up for you, all right? So you can watch it hopefully during study hall. Did you miss the whole thing? Like 7 minutes or so? Okay, well, that's probably an important 7 minutes because this was all new stuff. So make sure and go back and watch the video, all right? Okay, well, you guys, I have you for study hall. Yeah, our test is at Friday at 8. Do we need to check in for 7th? Nope, let me just make sure and check everybody's here. Yeah, everybody's here, so consider yourself checked in for study hall, okay? You don't need to check in again. And I am gonna log off our Algebra 2 meet. I'm gonna open up the 7th hour meet, but you just need to get on there if you have questions. And that's it, so have a wonderful day.